Okay, so now running through some of this review. So first thing we see, it says, what are the diatomic 7? So on your periodic table, what we got to see when we went over that was that we can start at the number 7. We're going to make a 7. Okay, so we start at the number 7. We create that 7, and we go all the way down to iodine. And if you count them, that's 1, 2, 3, 4, 5, 6. So our 7th one included is hydrogen. So the answer for that, you can just you can draw yourself a little picture, NOFClBri. And you're making a 7, you're starting at the number 7, and then hydrogen is your 7th one. The diatomic 7 have to have a little 2. So for example, nitrogen has to have that little 2 when they are by themselves. So required if alone. They have to be diatomic, meaning 2 of them have to be there. Okay, next question. We have, in the following equation, what are the reactants and the products? That's pretty easy, but before we totally dive into that, the first thing I want you to notice, this is kind of straight from your lab. You had dropped some zinc into hydrochloric acid. Okay, so solid zinc or magnesium into hydrochloric acid, and you had bubbles, right? So that was that bubbles idea. And this part, this is incorrect. This should not be an L. This should be an AQ. Remember, our L's we're going to designate for only our water, and then anything that's melted. Okay, so that one first, change it to AQ. And then for your reactants, remember reactants are on this side, products are on that side. So we're going to go ahead and say reactant 1, magnesium. The state of matter was a solid. Reactant 2 was HCl, or hydrochloric acid, and that state of matter was aqueous. Okay, your product 1, H2, so hydrogen, and then we have a gas. Remember that little 2 is coming from this idea of our diatomic 7. Product 2, we have MgCl little 2, and it should be aqueous. Okay. Okay. Aqueous just means that it's dissolved in water, so it means a solution. Okay. All right. During an exothermic reaction, energy is released. Exothermic reactions feel hot. Okay, so temperature is going up because basically what's happening is energy is being released into the thermometer, and that's what raises that temperature up. All right, then we have predict products for the following synthesis reactions. So again, you're not going to necessarily be asked to do the crisscrossing totally, but you should be familiar. A lot of these you should know where those subscripts are coming from. And remember, you don't touch subscripts once they're made. So here we see that we have 2 singles. So this is probably a synthesis reaction. So knowing that, I'm going to go ahead and combine them. So I have calcium and nitrogen. So the part about the charges, we would look at our little resource page. That tells us that calcium had a +2, nitrogen was a -3, and then we do that drop and cross. So that means a 3 goes here and a 2 goes here. Okay? Most likely, this is talking about a solid, gas, solid. And remember, just because it doesn't look balanced doesn't mean you mess with any other subscripts, right? That's where the balancing would have come in. So we would have had probably a 3 in front of the calcium, and then a 1, 1, and that would have worked. Okay. Here we have aluminum and sulfur, so again, alone, so it's another synthesis reaction. So when we combine them together, we have aluminum and sulfur. This is a +3 charge, this is a -2. I'm just getting that from our resource page that we have. We're going to cross and drop, so we have a 2 here and a 3 right there. If we were to go and balance this, we would probably have to double this, triple that one, and then a 4 in front of the aluminum. Okay, and this is a solid, probably a gas, and then it would be a solid over here, but I'll leave that off for now. The products of a combustion reaction. So no matter what, combustion reactions, okay, they're exothermic, and they always have CO2, H2O. No matter what, you will be asked that question, so make sure you know that. Okay, it's an easy question, but you got to remember it. All right, energy is absorbed during an endothermic reaction. Remember, endo, enter. Energy enters. Exo, exit. Right? Endothermic reactions feel cooler or cold. Temperature will decrease because it's absorbing energy from your hand, okay? And that causes it to feel cold on your hand, or absorbing energy from the thermometer, so temperature will drop.